Hi friends, today we are going to learn about permutations and combinations. First we'll see what permutation is all about. Permutation is basically the process of arrangement of one or more objects or an entire set of objects. Let's see with an example. Consider we have three objects A, B and C. So we'll see the possible ways by which how we can arrange them when we are taking all the three objects at a time. The possible ways of arrangements are ABC is one possible way of arranging it. ACB is another possible way. Similarly, BAC, BCA, CAB and CBA. So these are the 6 possible means by which you can arrange these 3 objects when you are taking all the 3 at a time. Now if you are taking only 2 objects at a time, how we can arrange them? You can arrange it as AB, AC, similarly BA, BC, CA and C. See, we arranged only taking 2 objects at a time. That's also 6 possible arrangements are possible. So this is how you use permutations to arrange the objects either as a whole or taking one or more objects at a time. Now we'll see how combination is different from permutations. Combination is basically a selection process where you are selecting one or more objects or more than one objects at a time, or you are selecting the entire objects at a time. Let's also explain it with an example. Consider there are 3 girls, okay? P, Q and R. These are 3 girls that are possible. So how you can select 2 girls out of these 3 girls? What are the possible means by which you can select them? Either you can select PQ, right? Or you can select QR, or you can select P and R, right? These are the only 3 possible means by which you can select 2 girls out of the 3 girls, right? You cannot do it as QP, right? Because QP and PQ, it's the same. That is the difference of how permutation and combination is different. In permutation, the order is important, while in case of combinations, the order is not important or it is not relevant because PQ and QP, it's all the same. So that's how combination is all about. Now if you want to select 3 students or 3 girls at a time, the only possible means or method is selecting PQR, right? There is no other possible method because QRP and RPQ, it's all the same. So that is the difference between combinations and permutations, okay? Now usually in an aptitude exam, whenever a permutation or combination question is being asked, they don't actually prefer or they don't actually mention whether it is a permutation question or a combination question. Sometimes they do refer that, okay, do the permutation or do the combinations. In such cases where there is no mentioning about whether to do a permutation or combination, how do you actually identify them? Then you have to see whether in the question if it's given whether order is important. If order is important, then you can identify that it is a permutation question or it is an arrangement type of question. If order is not given any importance, then it is a combination type of questions. Usually the questions that are related with arrangement of numbers or arrangement of words are basically permutation questions. And the questions that are related with combination is usually selecting a particular set of persons or selecting a particular set of objects from a group of objects. All those are combination questions. In a permutation question, the question pattern will be like how many methods or means are there for arranging particular objects, or how many methods or means are there to do this permutation, or how many ways by which you can arrange particular objects. These are the usual patterns by which a permutation question is being asked. While in case of a combination question, the question pattern will be like how you can select 3 out of these 5 objects, or how many combinations are possible out of these 5, selecting 2 objects out of 5 objects, or how well you can select a particular set of objects from a group of objects. Similar are the type of question patterns in case of combination. Another type of method or another type of question is the repetition. Okay, in some or certain case of questions, it will be mentioned that repetition is also there. If repetitions are allowed, then you can select actually this P 2 times or Q 2 times. For example, if you are selecting two objects out of these three, then it is possible to select P P, Q Q and R R also, if in the question it's mentioned that repetition is allowed. If repetition is not allowed, then this particular selection process is not possible. So do keep in mind when you read a question whether it is mentioned clearly whether repetition is allowed or not allowed. Till now we saw the theory part of permutation and combination. Now we will get into the formulas that are applied in the problems related to permutation and combination. First is permutation. Permutation is represented by the formula NPR, that is, out of the n objects you want to arrange r elements. Then the formula is n factorial by n minus r factorial. The simplified form of this formula is n into n minus 1 into n minus 2 up to n minus r plus 1. Let's apply this NPR into a small problem and see. If there are 6 objects and out of which you want to arrange 2 objects, then the formula applied is 6 factorial by 6 minus 2 factorial, that is 4 factorial. Okay, or maybe directly you can apply this into this formula where you get it as 6 into 6 minus r plus 1, that is 5, which is 30. That's how you apply NPR into a small problem. Now in some cases you want to arrange all the 5 or all the objects that are there. Then in that case the formula is NPN. Suppose there are 5 objects and you want to arrange all the 5. Then simply you need to apply n factorial. That is 5 factorial, which gives 120. That's how you apply permutation in a normal problem. In some aptitude questions you find circular permutation also. Let's see how circular permutation is being done. In circular permutation is nothing but arranging the objects around a circular table. Consider there are 3 objects A, B and C which is arranged around a circular table. The possible arrangements are, if you are taking in this direction, that is clockwise direction, A, B, C, B, C, A and C, A, B. This is a possible arrangement where, as you can see, the elements are not being shifted or moved. So you can count it as only one single arrangement. Similarly, if you take it anti-clockwise, the possible arrangements are A, C, B, C, B, A and B, A, C. Here also the elements are not getting moved. So that's also taken as one single arrangement. So totally with 3 objects there are only 2 arrangements. So here is the formula n minus 1 factorial. That is, if there are n elements, then there are possibly only n minus 1 arrangements in a circular permutation. The basic idea is you keep one element stable and then you arrange or rearrange the other elements. That is, you are applying the arrangement only to the remaining elements, keeping only one in the fixed position. That's how you should solve a circular permutation problem. Now another possible question in an aptitude exam is distinguishable type of permutation. For example, if you have a lot of objects, a group of objects, and some of the objects might be of one particular type and some of the objects might be of another type. In such cases, how do you arrange them? Then you need to apply the formula NPR, which gives rise to n factorial by n1 factorial into n2 factorial into n3 up to nn factorial. That is, this n1, n2 and n3 are all basically the distinguishable type of objects in that group of objects. Now we will see all with an example or with a problem and then understand more about it. question, it is asked to find how many words can be made out of the word Bihar. How many letters are there in this particular word? As you can see, there are only 5 letters. So, from these 5 letters, how many words can we make? Each of this letter is an individual letter, it's not getting repeated. So, it is 5P5. All these 5 letters can be used to make any new word. 5P5, in the previous formula when I have explained, when you are using all the objects, the formula is NPN, that is n factorial. So, similarly here 5P5, which is 5 factorial, which give rise to 120. Now, the second part of the question was, how many words can be made out of the word banana? Here there is a special case, as in the case of the distinguishable permutation. You have to apply that particular case here. There are 6 letters in this word, and out of which A is getting repeated 3 times and N is getting repeated 2 times. So you have to consider that too when you are taking the permutation. So according to the formula, it is NPR, which give rise to n factorial by n1 factorial into n2 factorial into up to nn factorial. Okay. So this n1, n2 are the number of times each object is getting repeated. In this particular case, n factorial is the number of elements in this word, which is 6. That is 6 factorial by n1. Here n1 is the number of times A is getting repeated, which is 3 factorial into the number of times which n is getting repeated, which is 2 times. And now only B is remaining, it's not getting repeated, so you needn't mention it here, or maybe we can write it as 1 factorial. Okay, it doesn't make any difference. So 6 factorial by 3 factorial into 2 factorial, you can simplify it. 1 into 2 into 3 into 4 into 5 into 6 whole divided by the 3 factorial, 1 into 2 into 3 and again 1 into 2, which you can cancel off the common terms, which gives the answer 60. So 60 words can be made out of the word banana and 120 words can be made out of the word Bihar. Mentioned that you need to find out how many words can be made out of the letters of the word daughter, okay, keeping the vowels together. Let's see how we can solve such kind of questions. Here the vowels are A, U and E. You need to separate the vowels from these consonants. The consonants are D, G, H, T and R, and the vowels are A, U and E. This vowels you can take it as a single entity so that you can consider it as a letter itself. So there are totally 5 plus 1, 6 letters. Out of the 6 letters, how many words can we make? It is 6 factorial, right? So total number of possible words that can be made out of the letters of this daughter keeping the vowels together is 720. And another thing is, these 3 letters or this entire entity, they can also be arranged, right? This E can come here or A can come here. Similarly, there are 3 factorial possible ways because there are 3 letters. So 3 factorial possible ways in which you can arrange these vowels as such. So 3 factorial ways are there. Okay. So now this 6 factorial into 3 factorial is the total possible number of words that can be made out of this particular word keeping the vowels together, which give rise to 720 into 6, which is 432. Now the second part of the question was to make how many words can be made out of the letters of the word extra, keeping in mind the vowels are not together. Okay, so how do you find such kind of questions? In this case, there are 5 letters, and so totally the total number of words that can be made out of 5 letters is 5 factorial, that is 120. And then you need to find out this case, that is how many words can be made where the vowels are kept together. Okay, when the vowels are together, how many vowels are there? E and A, right? So when the vowels are together, X, T and R, 3 consonants, and E and A, 2 vowels made into a single entity. So totally there are 4 letters. So it is 4 factorial, which is 24. Okay, and then similar to this case, there are here 2 letters, so there are 2 factorial ways in which E and A can be arranged. So that is 2 factorial 2. So the number of words that can be made out of the letters extra keeping the vowels together is 2 into 24, which is 48, and total number of words that are possible using all the letters of this is 120. So as per the question, it is how many words can be made out of the letters of the word when the vowels are not together. How can we find out? You can subtract this number of words which vowels together from the total number of words, right? So 120 minus 48, which gives to 72. So 72 is the answer.